So what's this chapter going to be all about? Here's your first test. It's actually about testing, hypothesis testing. And we're going to kind of introduce that idea of hypothesis testing today. We're going to talk about writing, specifically writing hypothesis, and some of the other basics that are going to get us into the idea of these things called hypothesis testing. So, so far we've talked about the idea of statistical inference, kind of making conclusions, being able to draw conclusions about statistics. There's really two different methods. Confidence intervals, which we've been introduced to so far, we'll do more of. And then today we're going to start talking about these things called significance tests, also called a hypothesis test. All right? Now, a significance test is a formal procedure for using observed data to decide between two complete claims called hypotheses. Claims are usually statements about parameters. Okay, remember parameters? We're working with parameters. They go along with population. So as a review, what are parameters? Parameters are some sort of value that describes the population. Now, there's a couple of main ones that we worked with, but mu would be one of them. That's the true mean, population mean. P, that's our true proportion. We'll also work a little bit with sigma, but that just is the true standard deviation. Okay, those are our common parameters. Now, since these are called hypothesis tests, we need to talk about hypotheses. Okay, so when we're dealing with hypotheses, there are two types of hypotheses. Okay, one is called the null hypothesis. It's also called H naught. That little sub-0 or sub-O at the bottom is a naught. So H naught, it's the claim we seek evidence against. Okay, often the null hypothesis is a statement of no difference, the default belief about a parameter's value. Okay, whereas the alternative hypothesis, which is H sub 1, or sometimes H sub A, is the claim about the population that we're trying to find evidence for. Okay? It's our unproven belief about a parameter's value for which we have to gather evidence. We're going to try to test. So, an example, we're going to look at some examples of these. Here's one. A free throw shooter claims that his or her long run proportion of made free throws is 0.8. We suspect that the player is exaggerating. So H naught is the assumption. Okay, it is the thing that we claim to seek evidence against. So the claim is P equals 0.8. Our alternative hypothesis, H sub 1, is specifically, we think so we think that's too high. It just depends on the situation. In this case, we're going to say less than 0.8. So this is what's given. This is what we think. We're going to use those to test. All right? So in any significance test, the null hypothesis has the form H sub, or H naught is the parameter equals some value. Mu equals this. The alternative hypotheses, however, are going to be either less than, greater than, or not equal to the value, because it's something that's not the same as the alternative. Okay? So to determine the correct form, read the problem carefully. Now, there's also, when we're looking at those less than, or greater than, or not equal to, that kind of determines if this is a one-sided or two-sided test. So a one-sided test, I'll kind of show this at one at a time, is where the alternative hypothesis is one-sided if it states that the parameter is larger than the null hypothesis, or if it's less than, smaller than. So basically, if you see a less than symbol or a greater than symbol, that is going to be a one-sided test. Meaning, when we, like, if we look at a normal curve, which oftentimes we will, we've got our mean, which is potentially the null. But whatever it is, if it's less than, we're looking for anything less than a specific value. If it's greater than, we're looking for anything greater than a specific value. Those are two different ones. Okay? Two different tests. And maybe I should draw it two different ways. I probably should. But, just like magic, I did. It's going to be a one-sided test. Whereas a two-sided test is where you see the not equal to. So a two-sided test is if it states that the parameter is different from the null hypothesis. It doesn't say if it's greater than, less than, it just says different. It could be either larger or smaller, so that's where it's a not equal to. And when you look at like a normal curve, we have our mean in the middle. It could be less than a specific value or greater than a specific value. It could be either one. All right, and that's why it's a two-sided test. So knowing a hypothesis, if a hypothesis is one or two-sided, will help us determine the p-value of the test as well. So we'll get into that next lesson. Now, I want to talk a little bit about writing hypotheses. We did one example of that, but I want to look at some other notes here. So writing hypotheses, always define your parameter first. That's going to be the same first step that we're always going to do. We want to state what it is, like P equals the true proportion of blank, or mu equals the true mean of blank. Because then once we have that, we're going to be utilizing that in our hypotheses. So the hypotheses should express the hopes or suspicions we have before we see any data. It is cheating, technically, to look at the data first and then frame a hypothesis to fit what the data show. Because then our hypothesis is going to be met if we look at the data first. So we don't, like, you make your hypothesis, you test the claim, and you see if you were right, or if you have evidence to support. Hypotheses always refer to a population, not a sample. So be sure that you're stating H0 and H1 in terms of the population, which is why we want to state those population parameters first. It is never correct to write a hypothesis about a sample. So this kind of goes along with that last one. Such as p hat equals this or x bar equals this. Those are not okay. We are making hypotheses about a general population. All right? So, we're looking at a couple examples here where I want you to identify the parameter and then state your two hypotheses, the null hypothesis and the alternative hypothesis, and we can determine if it's a one-sided or two-sided based off of that. So here's my first example. Mr. Bauer claims that fewer than 20% of Hamilton High School seniors cheat on tests. That's his claim. Okay, so our parameter has to do with a proportion. P is the true proportion of Hamilton High School seniors who cheat on tests. Now, based off of that, we can create hypotheses. The given is that 20%. Okay, so that given thing is going to be our null hypothesis, and it's going to say that P is equal to 0.2. And then our alternative is based on what we have a hunch or feeling or think about that. In this case, Mr. Bauer thinks that it's fewer, so less than 0.2, which makes it a one-sided test. This is a one-sided. It's less than, so it's on the left side. So it's actually going to be called a left-tailed test. So you might see it as left-tailed or one-sided test to the left. Let's look at another one. Same question here. This one says, Paul believes that his mice can finish the maze faster than the stated average of 2 minutes. Okay? Now you see again that 2 minutes. This is not dealing with a proportion this time. It is dealing with an average or a mean. So again, the difference here is we're looking at an average, an actual time. So an average of 2 minutes, that's where it's different than the last one. Now the question is asking, or is stating that the average is 2 minutes. So that means we've got a null hypothesis that mu is equal to 2 minutes. But our alternative, he says that Paul thinks that it can finish faster than that. So that doesn't mean it's greater than 2 minutes. That means it's less than 2 minutes because that would be slower or less time, so it'd be faster. So again, this again is going to be one-sided, and it is a left-tailed. Okay. All right, third one. Meta reports that the number of ads users see on Instagram has a standard deviation of 4.5 ads per hour. Mrs. King suspects that Meta is underestimating the variability based on all the ads that she's seen. So what would be our parameter for this one? So again, this one is standard deviation. So we would say mu is this, sigma equals the true standard deviation. Again, we want to use that word true because we're looking at the proportion, or the population parameter here. The true standard deviation of the number of ads Instagram users see per hour. Don't say anything about any specific sample or experiment. We're just looking at the true standard deviation. And that helps us with our null hypothesis. The null hypothesis would be that sigma equals 4.5, you can say, ads per hour. That would be our label. But our alternative would be what we suspect. Mrs. King suspects they are underestimating. So she thinks it's actually higher. She thinks sigma would be more variability, greater than 4.5, which makes it a one-sided right-tailed. Let's look at one more example. How about this one? Same deal. A Gallup poll report revealed that 72% of teens said that they seldom or never argue with their friends. Yvonne wonders whether this result holds true at Hamilton High School, so she surveys a random sample of 70 students at her school. So, our parameter deals with a proportion, so it would be the true proportion of Hamilton High School students who rarely argue with their friends. And again, that helps us with our hypotheses. The null hypothesis for this one would be that P equals 72% or 0.72. The alternative, she just wonders whether this holds true. So it doesn't say she thinks it's more or less. That means we're going to say P is not equal to 0.72. We don't have enough information to say she's assuming higher or lower. So this also is not a one-sided, this is a two-sided test, or a two-tailed test. All right? So that's the idea of looking at hypothesis testing. I'm going to leave you with one slide here that I think you should see, that you should write down, because this is going to lead us into our next lesson tomorrow. This is the recipe for hypothesis testing. It is very similar to a recipe for confidence intervals, but there's some slight changes. So number one is still to state the parameter. Number two, this is one that's different. We want to actually state the hypotheses right away. Everything is based off of the hypotheses, and we just worked on writing hypotheses, so this is important to a hypothesis test. Then state the test name, check the conditions, those are all familiar things. Write the formula, plug and crunch, find the p-value. We'll talk about that next time. And then we'll either reject the null hypothesis in favor of the alternative, but we're not going to say that we proved the alternative. We'll just say we reject the null. Or we fail to reject based off of, I'm going to change that. It should say null hypothesis there. But we'll either reject or fail to reject the null, and then that'll help us conclude something about, in context, about the alternative hypothesis. that is our recipe that we're going to get into next time. But this is just our intro to hypothesis tests. Hopefully you got an idea of writing hypotheses in particular and the general idea of what a hypothesis test will be. We'll see you next time.